she goes again, racing through my brain, and I just can't contain this feeling
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and there she goes again, indeed. And she is the beautiful mathematics. Yes, I just can't contain the feeling that remains. All right, let's get to it, shall we? This is Binary Operations Part 4, and today we are focusing on the identity. Right there, you saw in arithmetic, the additive identity is 0. So we're looking at the identity property of addition. And all that says is that I can add 0 to any number and I still get that number. And why the word identity? Well, the number, after being added to 0, still keeps its same identity. That's why it is the identity property of. So we'll get rid of that. And you can see the additive identity property says that a plus 0 equals a and 0 plus a equals a, where a is any real number a. In other words, the number does not change its identity. We have the same thing in arithmetic for multiplication. The multiplicative identity is 1. So before, the additive identity was 0. And the multiplicative identity is 1 because if we multiply anything by 1, we get that same number. The number retains, it keeps its identity. So we have the multiplicative identity property. Multiply any number, any real number by 1, and that number will retain its identity. Pretty cool, huh? Well, what about in other operations besides addition and multiplication? What about binary operations? Yes, there do exist some identities, and it depends on the operation whether or not one exists. And in a nutshell, all this says, if we have some operator star and some identity E, where we operate E star X is equal to X star E, so you got the commutative property going, equal, and the result is still X. In other words, that number retains its identity, then E is said to be the identity element for the binary operation, the star, on the set S. Now, let's just go back so we understand what they're saying by E. The identity for multiplication is 1. That's the identity property. That is the identity for multiplication. It's 1. So that would be our E. And for addition, it's 0. That would be what they're talking about as the identity, or naming it E here with this definition. Okay. Identity element for a binary operation on a set is unique. In other words, once you find an identity on some set S, some set of numbers S, that is the only one. There's only one identity per set if the identity exists at all, because many times the identity does not exist. An identity does not exist. This is a proof of Theorem 2 by contradiction. I'm not going to go through it. It's beyond the scope of the course at this point. But if you'd like to, you can pause the video and just read through it. Okay, so let's give this a whirl here. Determine whether an identity element exists in the real numbers, the set of real numbers, for each of the following operations. And the first one we're going to take a crack at here is A star B, and that is defined, that binary operator is defined by 3 times A times B, or 3 multiplied by the first number multiplied by the second number, or perhaps element is a better word to describe that. Okay, so let's suppose that B is an identity element. In other words, there's some value of b, like for addition, remember, it's 0, and for multiplication, it's 1. There's some value b that is an identity element which they refer to as E, for the binary operator star. Okay. Well, why didn't you pick A? Well, I could have picked A. It's the same thing because it's a generality here. It doesn't matter if I picked A or B, but generally we're always going to pick B just because of our traditional identity definitions. Well, if this is true, then if I perform the operation, the binary operation star, if I do A star B, then I have to retain A. In other words, A does not change its identity. Okay. Well, if A star B is equal to A, well, that implies that 3AB is equal to A. Why? Well, we have defined that operation, A star B equals 3AB. So I'm just replacing A star B with 3AB. And if this is true, just with a little bit of algebra, subtracting A from both sides, I get 3AB minus A is equal to 0. Then with a little bit of factoring, I get A times 3B minus 1 is equal to 0. And then if I solve for B here, 3B minus 1 equals 0, right? The zero product principle, then B would be equal to 1/3. Okay, so we got a potential identity element here, and that identity element would be 1/3. But if it's true, we must either prove or either show. We have two choices here. We can show that the binary operator operation is commutative. We can do that. Or, and we're going to do the or this time, or that B star A is equal to A. That's really commutative, but it's really going to, A star B, B star A is equal to A. In other words, A still retains its identity if we use the commutative property there. Okay, well, again, you have to think of these as placeholders. By this, this binary operation, if I have B star A, it's just the A's and the B's switch, then it becomes 3 times B times A, right? Well, we are claiming or hoping that an identity element is 1/3 for this set and this binary operation here. Okay, well, then we're going to replace B with 1/3, okay? And so we would have 3 times 1/3 times A. Well, I believe 3 times 1/3 is 1A, which is equal to A. So we have shown that B star A equals A, and A star B equals A. So we can then state, as required, an identity element exists and equals 1/3. And it's unique. That's the only identity element for the set of real numbers and this operation, okay? Because it is unique, okay? All right, next example, last example. What about A star B being equal to 3A plus B, okay? Well, if I do the same thing here, let's see if I can copy this. Suppose B is an identity element for the binary operator star. I'm going to copy that. Actually, I'm just going to move it over. That's how I probably could have had it written by now, but I'm going to move it over. It didn't work. Okay, you get the idea. I guess I'll just rewrite it. Suppose B, just to be mathematically correct, B is an identity element for the binary operator star. Okay. Well, if that's true, then A star B has got to equal A. Okay. And that would imply that 3A plus B equals A. Because right here, A star B equals 3A plus B. So I'm just replacing A star B with 3A plus B. Right? You follow? Well, that implies, if I subtract 3A from both sides, that B equals negative 2A. And we can stop right there, boys and girls, and we can say, so an identity element does not exist. Think about why I know that immediately. Does not exist, sometimes abbreviated DNE, since, here comes the reason, see if you know it, it would not be unique. It would not be unique. Okay, why would it not be unique? Because this is general. A could be anything. We're on the set of real numbers. So there are an infinite number of possibilities here. And it was clearly stated by Theorem 2 on the previous slide, I believe. Yep. An identity element for a binary operation on a set is unique. So if we come down to a situation where it's not unique, then it is not, we do not have an identity element. Here we got to b equals 1/3. That is a single value. And then we had to test it, and it worked. And so it was an identity element because it is unique. This is not unique. Okay. So that's how she works. That's how we think about the identity element for a binary operator. Hope you enjoyed it. I know I did, and we will end and see how she's going. There we go. Again, she being mathematics. Hope you enjoyed it. I know you enjoyed it because mathematics is awesome with a capital A. And with that, I'm going to say, there she goes. I am out.